Imagine stepping outside tonight. The sky is clear. You look up, and something is wrong. There is a star that was not there yesterday. It is brighter than anything else in the sky. Brighter than Venus. Brighter than the full moon. It casts a shadow on the ground beneath your feet. What you are seeing is a star dying. Not slowly, not quietly. In an explosion so violent, it briefly outshines an entire galaxy of 200 billion suns. The question is, what would it actually look like? Not in a simulation, not in an artist's rendering, but to you standing in your backyard, looking up with your own eyes. The answer is stranger and more beautiful and more terrifying than you probably expect. To understand what you would see, you first need to understand what a supernova actually is. Because most people have it wrong. A supernova is not a star exploding outward like a bomb. It starts the other way, it collapses inward. Take a star roughly 10 to 20 times heavier than our own sun. For millions of years, it has been burning fuel in its core, fusing hydrogen into helium, helium into carbon, carbon into heavier elements, all the way down the periodic table. Each stage buys the star a little more time. But when the core becomes iron, the game is over. Iron does not release energy when you fuse it, it absorbs energy. The core, which has spent its entire life pushing outward against gravity, suddenly has nothing left to push with. In less than a quarter of a second, the core collapses. An object the size of Earth shrinks to something roughly the size of a city. The outer layers, which have been sitting on top of this core for millions of years, suddenly find nothing beneath them. They fall. At a quarter of the speed of light, they slam into the newly formed neutron star at the center and bounce. That bounce, that shockwave blasting back outward through the star, is the explosion you see from Earth. The whole process, from collapse to shockwave breakout, takes less time than it takes you to read this sentence. Now, the nearest star that scientists believe could go supernova in the relatively near future, on cosmic timescales, is Betelgeuse. It sits in the shoulder of the constellation Orion, about 700 light-years away. 700 light-years sounds safe. It is safe. A supernova would need to be roughly within about 50 light-years to cause serious damage to Earth's atmosphere. Betelgeuse is 14 times farther than that, so what you would see is pure spectacle. No danger, just the most extraordinary light show in recorded human history. Because the last time a supernova was clearly visible to the naked eye was in 1604, 400 years ago. Before the telescope, before electricity, before almost everything we think of as the modern world. The people who saw it had no idea what they were looking at. You would. Here is what the first night would look like. You step outside, and there, in Orion's shoulder, where Betelgeuse used to be, a dim orange star most people never even notice, there is now a point of light so bright it stops you mid-step. At peak brightness, a Betelgeuse supernova would reach roughly magnitude -12. To put that in perspective, the full moon sits at about -12.6. We are talking about a single point of light nearly as bright as the full moon, blazing from a fixed point in the constellation Orion. It would cast shadows, real sharp shadows, from your hand, from trees, from buildings. At night, from a star, you could read by it, not comfortably, but you could. And unlike the moon, this light would come from a point, a piercing, almost blue-white point. Because at peak temperature, supernovae burn extraordinarily hot, set against the dark sky. Hotter than anything you have ever seen a star do. It would be visible in broad daylight, a bright star you could find by looking toward Orion at noon, something no living human has ever seen. But here is where it gets even stranger, because this is not a single moment. This is a weeks-long event. The first hours and days would see the brightness climb. Then it would hold, a second moon in the sky, every night for weeks, maybe months at a dimmer level. Then it would begin to fade. But not simply and not quickly. A supernova's light curve, the shape of how it brightens and dims over time, is driven by radioactive decay in the debris. As the ejected material cools and expands, different elements decay at different rates, each one releasing a little more light. The glow would linger, dimming slowly over months. then years. Eventually, in the spot where Betelgeuse used to sit, there would be a small fuzzy patch. Not a star. A nebula, the expanding shell of gas and dust from the explosion, still spreading outward at thousands of kilometers per second, growing slowly visible through telescopes over decades. And at the center of that nebula, invisible to the naked eye, but detectable with instruments, either a neutron star spinning hundreds of times per second, radiating pulses of radio energy like a lighthouse, or, if the core was heavy enough, something even stranger, a black hole, sitting exactly where a star used to be. Now, here is a detail that most people never stop to think about. If Betelgeuse went supernova tonight, if the shockwave punched through its surface at this exact moment, you would not see it for 700 years. Light travels fast. Nothing in the universe travels faster, but 700 light-years is 700 years of travel time. The explosion happening right now, in this moment, would arrive at Earth around the year 2724, which also means it might already have happened. Betelgeuse could have exploded 600 years ago, and the light is still on its way, racing toward us at the speed of light, arriving in 100 years, or 50, or 10. We would have no warning, no advance signal, just a new light in the sky. One evening, without announcement. Astronomers have noticed Betelgeuse doing unusual things in recent years. In 2019 and 2020, it dimmed dramatically. Enough that people started asking questions. It turned out to be a massive dust ejection and a surface cooling event. Not the end. Not yet, but it reminded us that this star is not stable. It is old. It is enormous. It is restless. The last naked-eye supernova we have strong records of was called SN 1604, Kepler's supernova. Johannes Kepler tracked it. It sat in the sky for over a year, visible in daylight for weeks. Before that, in 1054, Chinese and Arab astronomers recorded a guest star in the sky so bright it was visible for 23 days in full daylight. What they saw was the death of a massive star about 6,000 light-years away. Today, that remnant is still expanding. We call it the Crab Nebula. Every civilization that looked up and recorded what they saw, they left accounts of these events. Stars that appeared without warning, burned for months, and vanished. They did not know what they were seeing. We do, and we have not seen one, not since 1604, not in over 400 years, which means we are, statistically speaking, overdue. So, back to the original question, what would a supernova look like from Earth tonight? It would look like a second moon that does not move, a point of burning light in a fixed place in the sky, casting shadows, visible at noon, hanging there for weeks before slowly fading. It would be the most dramatic thing any living human has ever seen in the night sky. And then, over months and years, that point would fade, and a nebula would bloom in its place. A scar in the sky. An expanding monument to a star that burned for millions of years and died in a fraction of a second. And somewhere at its center, either a tiny spinning neutron star throwing out radio pulses like a cosmic clock, or a black hole, silent and dark, where a star used to be. It could happen tomorrow. It could happen in 100,000 years. But when it does, and eventually it will, anyone standing under a clear sky that night will see something no human alive has ever seen. Look up at Orion tonight. Find that reddish shoulder. That is Betelgeuse. That is a red supergiant star in the final chapter of its life. Unstable, enormous, burning through its last fuel. It will not last forever. Neither will the wait. If that made you look at the night sky a little differently, hit subscribe. There is a new video every week on the things out there that are worth knowing about. Next time, we are going somewhere even stranger. What actually happens to the matter that falls into a black hole? Not the science fiction version, the real answer, and it is genuinely unsettling.